alkynes are unsaturated hydrocarbons. They contain at least one triple bond between two carbon atoms. That means what are alkynes? Alkynes are unsaturated hydrocarbons. They contain at least one triple bond between two carbon atoms. The general formula of alkynes is CnH2n, where n is equal to 2. Where n is equal to 2. The first member of alkynes is ethane, and the second member is propane. The first member of alkyne series is ethane, which is popularly known as acetylene. Acetylene is the hydrocarbon, common name of the ethane. So if we go in detail and the nomenclature, if you want to know the nomenclature of these hydrocarbons, then we should know the molecular formula. The first member of alkynes is C2H2 is the molecular formula and containing one triple bond between carbon-carbon and two hydrogens and two carbons. This molecule it's commonly called acetylene, and its IUPAC name is ethane. Similarly, the second member is propane, C3H4. So CH3C triple bond CH. It's commonly called is methyl acetylene. So its IUPAC name is propane. The C4H6, CH3CH2C triple bond CH, ethyl acetylene, which is called butane, and C4H6 can be written as CH3C triple bond C, CH3 dimethyl acetylene is a common name, and it is the IUPAC name is butane. So but means 4 carbons, prop means 3 carbons, eth means 2 carbons. And so if we talk about the isomerism shown by these alkynes, ethane and propane have got only one structure. That means ethane, propane do not exhibit isomerism. So, and but there are two possible structures can be written for butane. But1-ine, but2-ine are the two isomers can be written for the butane. So, and since these two compounds differ in their structures due to position of triple bond, they are known as position isomers. That means alkynes exhibit the position isomerism. The next alkyne with molecular formula is C5H8. Let us try to arrange the 5 carbon atoms with the continuous chain with the side chain. The following are the possible structures. The pentane, you can look at this structure. The pentane has the pentane CH3, CH2, CH2, C triple bond CH. There is one triple bond between first and second carbon. This is one pentane. There is pent2-ine, there is 3-methyl-1-butane. Look at this. This is a branched isomer. These are the two position isomers. Totally 3 structures we can write for C5H8. Structures we can write. And how many different isomers we can get for the 5th member of alkyne series, and write the IUPAC names of all the isomers. So what type of isomerism exhibited by the different pairs of isomers? If you want to look at the structure, C6H10 is called hexane. The hexane formula is molecular formula is C6H10. The C6H10 is the alkyne. So how many isomers it can exhibit? The hexane can exhibit so the position isomers and structural isomers also it can exhibit. Number 1, so the carbon atoms, hexane consisting of 6 carbon atoms, 1, 2, 3, 4, 5, 6. You can write triple bond between first and second. So when we can get one hexane, we can get. If we arrange the triple covalent bond between second carbon and third carbon, this is 2-hexane we get. And if you arrange the triple covalent bond between third carbon and fourth, then 3-hexane. So then 3 positional isomers we can get in this C6H10. And so structural isomers, if you write carbon atoms 1, 2, 3, 4, 5 in the normal chain, means in that continuous chain, if you write, and if you take the 6th carbon as a branch, so then we can get how many isomers, the structural isomers we can get 1, 2, 3, 4 structures we can get for the same molecule hexane. This is 4-methyl, 1-pentyne. This is 3-methyl position of this methyl group on third carbon, then 3-methyl, 1-pentyne, and 4-methyl, 2-pentyne. And next, one means here 1, 2, 3, 3 comma 3 dimethyl. So but-1-ine. We can get the isomers total altogether isomers. How many we get means 3 position isomers we get 4 branch structures we get, altogether we get 7 isomers we get for the hexane, including the position isomers and the branched isomers we can get. So alkynes, similar to alkenes, exhibit position isomers, and also the branched isomers we can see from these alkynes. And similar to alkynes also more reactive due to the presence of the pi bond electrons. But as you compare with the alkynes are less reactive. So if you want to know the reactivity of alkynes, we must study the structure of triple bond present in alkynes. Alkynes having the triple covalent bond, whereas alkenes having double covalent bond, alkanes having single covalent bond. So, and why alkynes are less reactive than alkenes? So, if you want to know the reason, then we have to look into the structure of triple covalent bond present in alkynes. And if you observe the alkynes, example, ethane, if you take, ethane is the molecule having C triple bond C, it has. So in this, each carbon undergoes sp, each carbon atom in ethane undergoes sp hybridized orbitals. The sp hybrid orbitals between carbon-carbon will form one sigma bond, which is formed by overlapping of 2 sp orbitals of both carbon atoms in ethane, where the triple covalent bond is present. So the remaining sp hybrid orbitals of each carbon will overlap on the internuclear axis with 1s orbital of hydrogen. 1s orbital of hydrogen. There are 2 hydrogen atoms are present in ethane, so will form CH bonds. How many CH bonds? 2 CH bonds will form. The structure, the overall structure appear to be linear because the sp orbitals are oriented on the same line, and the bond angle, it will make 180 degrees, the bond angle it will make. As the sp orbitals overlap by end on end, and with the 1s orbital of hydrogen atom, so all these orbitals lying on the same plane, so hence the bond angle is 180 degrees, but there are unhybrid pure p orbitals left on each carbon, which are lying perpendicular to each other to the plane of CC bond, CC sigma bond. The 2p orbitals of one carbon atom parallel to 2p orbitals of other carbon atoms will overlap sideways. So then 2 pi bonds are formed in ethane molecule, or where the triple covalent bond is present, there 2 pi bonds are formed. 2 pi bonds are formed. The strength of the triple covalent bond between carbon-carbon, the bond enthalpy is around 823 kilojoules per mole, which is more than the C double bond C bond enthalpy of double bond is 681 kilojoules per mole, whereas that the C single bond, so bond enthalpy is 348 kilojoules per mole. So the triple covalent bond length order is 120 picometers, very shorter bond wavelength, whereas the double bond is 133 picometers and the single covalent bond is 154 picometers. The electron cloud between the carbon atoms cylindrically and symmetrical about the internuclear axis. Then ethine is a linear molecule. The ethine molecule seems to be, look at this structure. This is a carbon sp hybrid orbitals, two sp orbital. This is one sp orbital, this is another sp orbital. Similarly, next carbon also having sp orbital and sp orbital. And the 1s orbital of hydrogen overlap with sp orbital of the carbon, and sp orbitals of one carbon overlap with the sp orbital of another carbon. This is end on end overlap resulting one sigma bond, and sp orbital of another means sp orbital of the carbon, another sp orbital overlapping with the 1s orbital of hydrogen, and finally making, so number of sigma bonds how many? So between carbon hydrogen one sigma bond, between carbon carbon another sigma bond, and carbon and hydrogen another sigma bond. So all the orbitals, sp orbitals and 1s orbitals of hydrogen lying on the same plane, then the bond angle, so resulting how much bond angle we can get means 180 degrees we can get. Let us see in detail in the ethine molecule. Means if you take alkyne where the triple covalent bond is present, the both carbon atoms having leftover unhybrid pure p orbitals. There's a 2px and a 2py are present. These are present perpendicular to each other, perpendicular to to the hybrid orbitals we say. And when these orbitals overlaps, so side on side overlap, they can result what means pi bonds they can form. So, and that means here in alkynes, so alkynes and two pi bonds, one sigma bond is formed. Two pi bonds and one sigma bond. So totally between carbon carbon atom there are three bonds are present. Bond order is 3, and since the bond order increases, the bond length decreases, then the bond enthalpy increases. And also another thing we have to discuss in ethine or in alkynes is that since the hybridization in the alkynes is sp hybridization, then the S character increases in sp hybridization. Due to this, the electronegativity of the carbon increases. Due to increasing of electronegativity of the carbon in alkynes, so then the carbon atom will get more electronegative character, negative tendency will increase. Due to this, it can retain the electrons between hydrogen and the carbon. Then, so the hydrogen easily can be displaceable due to the high electronegativity. The hydrogen can be easily displaceable. Since hydrogen can be displaceable easily, then alkynes exhibit acidic character. Easily they donate the proton, easily the proton can be displaceable in case of alkynes. Comparison with the alkenes and the alkanes, so alkynes having more acidic in nature. So, and it can be known by the evidence that alkynes react with the metals like silver and copper and sodium and form and releases hydrogen gas. Hydrogen gas we can get. So with this we can understand that alkynes having more acidic property than, so comparison with the alkenes and alkanes. Because so the carbon atom present in the triple covalent bond or means the carbon atom, so undergone sp hybridization, will exhibit more electronegative nature and more withdrawing electrons property from the CH bond. Then the easily proton can be removed, displaced when they react with the metals like silver, copper and sodium. Hence they form the compounds easily: silver acetylide compound, copper acetylide compound and sodium acetylide compound. They can form because of acidic character, because of acidic nature. So this is the most important question that can be asked on these alkynes, acidic nature of alkynes. So why they exhibit acidic property? So why not alkenes? Why not alkanes? Because of the answer lies in the hybridization of the triple covalent bond of the carbon atom. So that means the properties of alkynes, the properties, chemical and physical properties, depends upon the structure of the molecule, particularly triple covalent bond in alkynes. So, and if you want to know about the chemical properties and the physical properties, then the next class will talk about the physical and chemical properties of alkynes.